Okay. We are starting exponential functions today, which leads us into logarithmic functions. This section here, for those of you that are taking pre-calculus, you're going to see this entire section again in that course. So we want to make sure that we do our due diligence here and get a good understanding of it. What we're looking at today is exponential graphs. So an exponential graph would be one in which your exponent for your equation is actually x now. So the last section we looked at was polynomial functions. And in polynomial functions, you had x to a certain degree. So your exponent was a numerical value on your x, and that told us what the degree is. So today we're looking at our exponent being an x value. Okay. Now, we're going to have a look at what happens. Actually, you know what? I'm going to do it on here. Okay, so the first thing that we're going to look at today is there's basically the main thing with this graph is there's four characteristics. So we're going to talk about exponential and logarithmic. Logarithmic sounds totally complicated, but basically it's the inverse of what an exponential graph is. So it's actually quite simple to do when we start talking about inverses. But for right now, we got to focus on the exponential part of this. And so the first equation I'm going to look at is y equals 2 to the power of x. So the graph looks like this. Now, there are four characteristics about this graph that we need to take note on. Okay? The first thing is the y-intercept. What's the y-intercept on this graph? 1. Y-intercept is 1. Is this graph increasing or decreasing?
Increasing.
Increasing. What is the end behavior of this graph, if I asked you what that was?
No. Yeah, 3 to 1, sorry.
3 to 1.
3 to 1 goes down below the x.
Or is it one of those ones that never touches?
2 to 1? It is one of the ones that never touches.
Okay. Yeah, I'm going to come back to that in one
So 2
second.
to 1.
So 2 to 1 is the correct answer. Now, let's go back to what you were just saying here. All right? The equation here I had was y equals 2 to the x, right? Okay? So now, if I just made myself a table of values, and I'm going to start with x being 2, 1, 0, negative 1, negative 2, negative 3. I'm going to look at those values. So I'm going to put those values in for x. So I put a 2 in for x. What is 2 squared? 4. So that's 2 and 4 right there, right? Okay. 1 and 2, that's right there. 0 and 1. So far, so good. Negative 1. So what's 2 to the power of negative 1?
2. Negative 2.
I'm looking for 2 to the negative 1. Yes.
Oh, yeah.
Okay. How do I make that exponent positive?
Multiplied by.
No, not multiply it. I put 1 over top of it. My exponential rules that we learned in grade 10. So I got 1 over 2 to the power of 1 because it becomes positive, so 1/2. So this is 1/2. What's 2 to the negative 2 then? 1/4. What's 2 to the negative 3? 1/8. So what's happening here as my graph goes to the left, okay? What's happening to my y values?
Smaller.
Smaller and smaller. Is it ever going to hit
No.
when y is equal to 0? No, it can't. So this brings us back to two more of the characteristics in this graph. Characteristic number 3, okay, so we got y equals 1. It's an increasing function, meaning it starts low and goes up, my y values, okay? My range for this graph is y is greater than 0, okay? And the equation of my asymptote is y equals 0. There technically is a line right there, which is an asymptote. Now remember what an asymptote is? It's a line in which your graph comes close to but never ever crosses. That's what an asymptote is. And the equation of that line is y equals 0. These 4 characteristics you have to know and remember. Hence, put on your cheat sheet. All right? So if I put in the equation y equals 4 to the x, what do you think happens here? What's going to change on this? If I put 4 to the x in here, I put a 4 there, what's going to happen to it? Yeah, that's right. It's going to go up steeper. There it is. Okay? Notice where it crosses still. At 1. Now how come it always crosses at 1?
It's your y-intercept. There's no...
Okay, and so what do I do to find my y-intercept at all times? Put in 0 for x. Any value to an exponent of 0 is always equal to what? 1. So when you have an exponential graph, it will always go through 0 and 1 if there's nothing in front of the equation itself. Okay? So these 4 things don't change. So far, so good? All right, again, that is cheat sheet material. All right. Now, I just finished looking at y equals 4 to the x. So the only way we change this is what if I put a 2 in front of it? So if I change this a value here, I have to look at what happens. Okay? So y equals 4 to the x was this. So what am I doing if I put a 2 in front? My intercept would change. That's right. My intercept would now be 2. Because what does this 2 do? What do I do to all my y values? Right. So I multiply them by 2. So essentially what's happening here then is, if I put a 2 in front here, multiply it, what happened to the graph? 0, 1 became 0, 2. I'm multiplying all the y values in this graph by 2, so it actually makes it go up steeper. So far, so good? Okay, so let's look at what happens here. Okay, my standard graph, y equals a, b to the x. Okay, that's my standard exponential graph. All exponential functions in the form f of x equals a, b to the x, where a is greater than 0 and b is greater than 0 and b can equal 1, have the following characteristics. The number of x-intercepts is 0. So that's the only thing I didn't write on that list. So look at that keep in mind box on page 178. All the information that you need is in that box. All of that information on that final arrow bullet needs to go on your cheat sheet. If you don't have it on there, it's your own fault, because that should be put on there. Number of x-intercepts is 0. Number of y-intercepts is 1. End behavior, the curve extends from 2 to 1. Your domain is x is an element of all reals, and your range is y is greater than 0, where y is an element of all reals. Okay, go ahead.
Can it not Can it like be flipped?
Yeah, I'm gonna get
3
to those.
4?
I'll get to those in a second, okay? All right. So far, we're following. That all needs to be on that cheat sheet. You should be able to identify that, look at the graph, and then go from there, just based on that information. Let's look at the example that they give us. Determine which of these two graphs represents an exponential. So which one of those two graphs, 1 or 2, is exponential? 2. For each function that is exponential, state. Okay, what are the number of x-intercepts on it? 0. What's the y-intercept on that graph?
5.
5. The end behavior?
2 to 1.
2 to 1. The domain? X and element of all reals. The range? Y is greater than 0. Done. That's it. That's all there is to 7.1. Okay? Any questions about 7.1?
Is this kind of like a graph that like, okay, is negative?
No. No, I'm gonna look at that next. 7.2. Yes.
Will all of them be y is greater than 0?
Okay.
Like all of these.
Let me
Or it could be less than 0.
show you. Let's look at 7.2, and then if I haven't answered that question, I'm going to show you how it works.
Yeah.
Basically, what it means is this: if I had something out here, I don't think we do that in this section just yet. But if I had something out here like +1, okay, then the whole graph would move up 1, and then it would be y is greater than 1 in that case.
Okay.
Okay, but I don't. For some reason, I don't think we do it in this class. I think we only do it pre-calc.
Okay.
All right? But if it happens, I'll point it out to you. Okay, so we need to know what happens when I change A and B. Okay? So right now, if A is greater than 0, A is greater than 0, this is what my graph looks like. Just like that, okay? So what happens if I make A a negative? What if A is less than 0? What happens to that graph then?
It's flipped upside down.
That's right. So in pre-calculus, we call that a reflection, meaning it flips over the x-axis. So all of these y values that are positive here, they all become negative. So it moves to the bottom here. So if A is less than 0, the whole graph flips to the bottom. What then becomes my x-intercept? Or my y-intercept, sorry. -1, right? What is my range in this graph? Y is less than 0. That's correct. Okay? Still no x-intercepts. All that happens is the graph flips down. So if A is greater than 0, opens up. A is less than 0, opens down. Your end behavior for this guy is 3 to 4. Okay? All right? In an exponential function, the form y equals a b to the x. A is a non-zero multiplier, and b is the base where b is greater than 0, b can't equal 1. The value of a is the y-intercept of the graph of the function. The value of b is the ratio of y values whenever the x value increases by 1. An exponential function is increasing if a is greater than 0 and b is greater than 1, and decreasing if a is greater than 0 and 0 is less than b less than 1. Okay, so the next most important part is that last bullet that I just rambled on about. If b is a fraction, then the graph is going to change to a decreasing graph. It's going to go like this. So if b is a fraction, it's going to go down and it's going to be a decreasing graph. Now I will show you why. So if I have y equals 1/2 to the power of x, okay?
Because it's like multiplying by like 0.5 each time.
No, it has to do with the negative. Okay? So if I put a negative here, right now I have, let me do this over here so that you can see the math behind it. Now you don't need to write this down, just watch so that you get the idea as to why. So I have this, 1/2 to the negative 3. That's like saying 1/2 to the negative 3. How do I make that exponent positive? What's my rule?
Put a 1 over it.
There already is a 1 over it. So then what do I do to make it positive now? Move it to the top. That becomes 2 cubed. So what is 2 cubed?
8.
8. So this is 8. So 1/2 to the negative 2 then is 4. 1/2 to the negative 1 is 2. 0, 1. So it still goes through that point right there, right? Okay. Now 1/2 to the power of 1 is 1/2. 1/2 to the power of 2 is 1/4. So it goes like this. Starts up here, goes through there, and then it gets smaller and smaller as this value gets larger and larger. Okay? You don't need to know. I just want you to see that that's what happens. So if your b value is a fraction, the graph becomes a decreasing graph going from 2 to 1. All right? We okay? So f of x is equal to 8 times 2/3 x. So it's between 0 and 1, correct? So what do we know about the graph then? It's decreasing. What is the y-intercept of this graph?
8.
8. Good job. It's like this. This y-intercept is 0 and 8. Because if you put 0 in here, 2/3 to the 0 is 1. 1 times 8 is 8. So it becomes 0 and 8. All right. How many x-intercepts are in that graph? 0. What's the y-intercept? 8. What's the end behavior? 2 to 1. What's the domain? X element of all reals. Is this function increasing or decreasing? Decreasing. We're done. Okay? You have Desmos. You can use Desmos for this section. It's probably the easiest. Okay? However, look at page 184. I got to go through this because these guys are gone the next 2 days, so we'll go to the end of 7.3. All right, so everything's said and done. Again, let's do a quick review here. How does A affect the graph? It changes your y-intercept. What else does it do? Okay, so if it's positive, what happens?
A is larger than B.
No. No, what happens if that A is positive? If A is greater than 0, what is it?
Oh, it's increasing.
It's increasing. Very good. And if A is a negative, it's decreasing, but it also does what? Flips. Goes below the axis. Okay? So that's just what we need to know. If B is a fraction, what happens to the graph? Change to a decreasing graph. Okay? So, now. Yes, sir.
If A is negative, but B is a fraction, it's increasing.
So you would have, okay, let's,
my mind there.
all right, so if B is a fraction, it looks like this, right?
Yeah, but if A
And then if A is negative, it flips over, so it's gonna go like this.
Oh wait, no, it's increasing.
It's increasing.
Oh, that's fun.
Okay? All right, question. All right, now, good catch.
Oh, ending snag.
All right. Now I told you last unit, that you need to know those steps. We are now using those steps again this unit. So we are going to do, instead of linear, quadratic, or cubic regression now, we're now going to do exponential regression. So get out your calculators. Have a look at the example on page 184. Use the year as your x value, your population as your y value, and put that into your stat mode.
Exponential regression is 0.
Sorry?
Okay.
For 0, would you continue with L1?
We do everything the same way as we did last section.
You want us to grab it?
Well, I need the equation. I want to start with that.
A is equal to
What is A?
1.9, not 2.
Sorry, 1.9.
It'd be 2. 1.9 and then.
I got 7. I got 8.45.
Same, I got 8.45.
For your
The
A?
negative 4,
Yeah,
yeah.
8.45, 2, or 3. 3.
Let's see it right.
Let's start with A.
What's he running?
Give me one moment here. What
I got
did you
the numbers exactly on the board.
Oh, you
How many of
did
you got
L1,
this?
L2.
No, you didn't.
Okay.
I just looked at it.
It did.
And who else didn't get it other than Brendan? Okay, let's have a look, Jules.
I didn't put L1 L.
Yeah, you got 2.0.
Yeah.
I think you plugged it in wrong there.
You thought you
Just
just
stick one on the chicken.
Just one wrong.
Yeah, but every night, just
My jacket.
Are we doing these?
Michael must take your jacket,
Yeah, that's what it is.
No.
put it in the chicken.
I wish he would go with teachers. He's also the most miserable kid in the world.
The one off the center, the kids on the bus stay with them. Yeah, sometimes she starts howling and there's one in there.
He probably deserves it. So miserable.
What's 0?
Okay, anybody else not get it? We're okay? Eli, Dylan, you guys are all right?
Yeah, just showing me this here.
Okay. So that's what I have right there. Now go zoom stat. Make sure your stat plot's on.
Zoom stat, yeah.
Is that what it looks like?
No.
Mine's straight.
Mine's very straight.
I know it looks straight. Okay. It's going to look.
Okay, X minimum
Oh, maybe it's
is
going up.
minus
Yeah,
20.
it's screwed up a little bit.
Okay. So it goes, should look like this. It should eventually look like that. Okay.
I can see it.
All right. Okay, so use exponential regression to define the function that models it. So we got to write our equation out. Assume that the same growth rate, estimate the population in 2020. Okay, so what do we got to make sure that we do? Window first, that's right. Make sure your window is larger, your X maximum is larger than 2020. So make it 2021. And then, what are you doing next to find out what it's equal to?
Enter 2020 into the X.
And what do you get?
1,349.525.
1,300.
49.52 or 53 or 525.
525, okay, good. Now, in theory, if I was answering that question, I'd also have times that by 1,000, right? Because if you look at your question, it's population as thousands. So I times that by 1,000 and I would get like 1,000,000 something, right? Okay, now the next thing says, so far, any problems with that?
Yeah, my graphing thing is being stupid.
I have no clue.
No
what I'm
matter
doing
how
right
many
now.
times I
just
try to
graphed
adjust
it,
my
that's all.
window, no matter how big
Just
or small it is.
2021.
Morgan, I want to find out what the population is going to be in 2020. So you have to change your window.
Zoom stats.
I did zoom static.
What did you put,
I've been trying to fix it. Oh,
yeah,
there
that's
we
your
go.
answer.
I'm sorry about my graphs on my calculator.
What was your Y minimum?
Here it goes.
Your stat plot is not on.
Zero Y.
That's it, turn your
My
stat
Y
plot
minimum?
on.
695.903.
Is it zero?
Yeah.
Okay.
Why is your Y-
Now, I told Eli this yesterday, and we just ran into it with Jesse. If you run into a situation where that graph doesn't show up, you need to know how to fix that, because on the exam I can't tell you. So that means that if your graph is not showing up when you go zoom stat, it means your stat plot is not on. If you graph an equation and it's not showing up, it might mean because your stat plot is on. So you have to just check your stat plot now. Okay, so you got to go back and forth. Yes, Morgan.
I got 1,359. I'm off by
Okay,
10.
we'll look at it after. Okay, Morgan. All right, now the last thing is,
What?
What's your
it says, when is the population going to hit 1.5 million people? So what do I have to put into my calculator now?
Y?
Yeah, what am I putting in for y?
1,500.
1,500, very good. So put y2 is equal to 1,500, and then at that point, what do I do?
Graph it.
Yeah,
And then find the intersection.
well done, well done. Graph it and then find the intersection point.
What's your code? Why not?
What'd you get?
190. Oh, 1983. Sorry, I didn't see that.
Why does it always freaking do this to me?
2030.
There we go.
2034.95.
So that's 2035.
I didn't hit enter.
Okay. Oh yeah.
This gave me a guess.
I don't know.
Hope we're figuring it out. There we go. Just kidding, it said error. Yeah, I got it. Error too.
Because you do it for thousands.
I never had it.
I mean,
Oh, yeah.
Move your window.
You just do like that.
Press enter.
Do you have 23?
I don't know. I'm still lost here.
Okay, Morgan, put in y2 1,500.
I did that and it didn't come up.
Well, let me see.
Check your window then.
I tinkered with my window, yeah. That's what I did. I'll see if it works though.
Okay, so it should have an intersection point, and Zane said it was 2034.95.95.
I got error.
Okay, so if you have an error, what do you check next? The window. That means that you have to have it larger than 2035, and then you have to have your x maximum larger than 1,500.
Oh my god, why did
What part has to be bigger than 2034?
Your x's, your x maximum.
Okay, I did that.
So you should fiddle with your window on this, and it should work out. Monday I'll get into 7.4. So I'm just gonna shut this down, and then I'm gonna walk around and help everybody, okay? Because there's lots of issues.
What did you want?
Larger than 2035.
I told you your x is 228.
I literally don't know what's going on.